So we're on section 0.3, solving equations and inequalities. There's a couple things I'm going to skip over just for the sake of time. So if you do want to look at those, you either look them up on your own or we can talk about them in class. But remember, when solving equations, these two cases, so this would be a good opportunity for you to pause your video and jot these down. We'll talk about these today. But when you're ready, you can unpause and we will go forward. All right, so if you needed to get those done, pause and go back. Okay, so first thing we're going to look at, later in the year, we're going to see some opportunities where these rational expressions, these rational equations will come up and we'll need to deal with them. So the big difference today is these are equations. You know, that's the big difference, obviously. That's what the lesson is called, equation solving. These have equal signs. So when I talked about in this simplifying video where I said you can only multiply by something that's equivalent to 1. So we could multiply anything by 2x squared over 2x squared. As long as we're multiplying everything by something that's just equivalent to 1, I can multiply by whatever I want. Now the great thing about equations is that there's an equal sign. I don't have to multiply every term by 1. So I don't have to, if I multiply this, I mean, we kind of see what's happening with my common denominator. If I multiply this by x squared minus 4, I don't have to multiply the denominator by x squared minus 4 as well. So to keep an equation balanced, and that's why I put that second bullet point up here. If you perform an operation to one side of the equation, you must perform the same operation to the other side. So I could multiply this side of my equation by 1 million if I wanted to, as long as I also multiply the other side of my equation by 1 million. So that's what we can use to our advantage when we're solving equations, which is so different than when we're just simplifying an expression. So this is something you've done in the past. We're solving this rational expression, this rational equation. So the first order of business is we always want to kind of factor here first to see what's going on under the hood. So I'm going to look at what's really happening with that last term. So now I see my overall common denominator, my GCF basically. Or I'm sorry, my LCD, my lowest common denominator. So I'm going to multiply every one of these terms by just this common denominator, x minus 2x plus 2. Again, I don't have to multiply this over x minus 2x plus 2. As long as I do every single term, if I multiply every single term, and I'll just do some grouping parentheses here. If I multiply every single term by x minus 2x plus 2, and I'll distribute here and here, then I'm not unbalancing my equation. I'm keeping it what it needs to look like. So what happens here, and then I'll pause so you guys can finish this one up on your own. This 8 over x minus 2x plus 2, this is really just over 1. Those x minus 2 terms divide out, and the x plus 2 terms also divide out. So this side I'm just left with a nice 8. Now be careful what's happening on the other side. They don't have all those terms included. But I'm going to pause and you guys can kind of finish this problem up. I'll work when I'm paused and you can check your work with mine when you're done. All right, try it now. All right, so there you have it. You can take a look at my work. Notice what divided out, you know, people use the term canceled out, but look at what divided out here. That's kind of the key. And then at the very end, I checked for an extraneous solution because we can't allow 0 to be in our denominator. Okay, so if that gave you trouble, let's talk in class. Otherwise, we're going to move on. So we're going to skip over questions 2 and 4. I do want to look at number 3. So here we're solving a quadratic inequality. And a really nice way to look at this is to look at it graphically. So we'll do that in just a second. But when we're looking at a question like this, the first thing I always think about, I want to find the critical points. I want to find when the x values make this equation equal to 0. So I don't care so much about the inequality yet. But I'm going to factor this. It turns out to x minus 7, x plus 2. We get x equals 7. X equals negative 2. Those are my critical points, or my critical values. That's what makes this equation equal to 0. Okay, but I don't want to know when it's equal to 0. I want to know when this stuff is greater than 0. So there's kind of two ways to do it. We can just put these two critical values on a number line. So just like you always used to do back in Algebra 1. So I have -2 here with an open circle, right? With an open circle because it's just greater than, it's not greater than or equal to. And I can test values in each interval. So I can test -10 in my equation. I can test 0, that's a nice easy one. I can put 0 into my equation. And I can test +10 into my, I guess it's an inequality, not an equation, and see which ones work. So if I were to quickly test those, test -10 for x, test 0 for x, test +10 for x, this section works and this section works. This one doesn't. All right, so when we're writing our answer, we know the values that satisfy this inequality are when x is less than -2 or when x is greater than 7. So we'll talk about set notation and interval notation in a couple days. I don't want to throw that at you yet. But really what's happening, if you were to think about this graphically, this is just a quadratic equation, a quadratic function with a positive x term. So we know it looks like this, right? This is just, if you were to sketch the graph, it would look like that. And I actually did it down here on my TI emulator. So if you look at the graph, there's my critical points. I'm asking you when this function is greater than 0. So the output is greater than 0, that way and that way. So that's kind of the way I like to think about it. I like to think about these questions graphically, all right, instead of doing little number line tests. But either way works. Either way, we get this for our answer, okay? So it's not just, we can't just keep the greater than symbol. That's a really common thing I see people do. They look at this greater than and they just keep greater thans all the way through, where we can see that doesn't really make sense. It doesn't match up with the graph. Okay, so we will work on that type of question in class. So let's skip ahead. We're going to look at number 5, completing the square. Everyone's like worst nightmare, at least it was when I was back in school. I think you guys do a little more of it now. It's really easy sometimes. Whoa, I don't want that. Go back. All right. Well, let me say it again. It's not really easy sometimes. Sometimes it's easier. So if I look at this question I have here, I probably don't want to, well, I guess we can first see if we can just factor it using our traditional methods, right? We can just see if we can have an add to -14, multiply to a -44, and if it works, great. These numbers are pretty big. Yeah, we could put it in the quadratic formula, x equals -b plus or minus the square root of b squared, all that, you know, the quadratic equation. I don't know if I want to do that. These numbers are a little larger. It's going to get a little bit messy. So this is a really good candidate to use completing the square. So if you recall, to complete the square, we want to get the constant to the other side. And completing the square is nice when the b value is even. So if you remember, what we have to do is think about what goes in this blank, right? What completes the square. So if you go back to your Windows method, we want to know what goes here. So all we have to do is take our b value, divide it by 2, and square it. So that's really what's going here and here. So we have our x and our x, the b value divided by 2, and that's how we get my 49 here. So -14 divided by 2 is -7. -7 squared is 49. So we have 49 here. We have 49 here. And our work is pretty much done. Now we just have to factor this. And the really nice short rule of thumb, whatever this is, that's what's going here. So since we squared a -7, this factors down to x minus 7 times x minus 7. So I'm just going to write it like that. 44 plus 49. Nice little mental math. Let's just do 44 plus 50. That's easy, which is 94. And just one less than that. That's how I get my 93. Okay? Solve it out. We have to take the square root of both sides, our inverse operation that undoes our square. So we're left with x minus 7. Careful here. There's two answers, right? This is a quadratic equation. I did say that wrong before. It's the quadratic formula, not the quadratic equation. I'm sorry about that. So we could solve this using the quadratic formula. My brain is still rusty from that long summer off. So we could solve using the quadratic formula. My guess is whoever did that would be here a lot longer than we are who are just completing the square. I add 7 to both sides. I get x equals 7 plus or minus square root 93. So that's a nice skill to have in your back pocket. We're going to get into some some more challenging equations with logarithms, with trigonometry later in the year, and this completing the square is going to be helpful. It does make things easier sometimes instead of having to do these huge quadratic formula steps. All right, I'm going to pause real quick. I'm going to see where I'm at. I think we're going to start the next question, but maybe we'll finish it together in class. So I'm going to pause while you guys take a look at that next one. Okay, so we're going to get started on this one. First thing I'm going to ask you, if I give you an equation, if I say x equals 3, and if I that's a true statement, x equals 3. But then if I were to square both sides, so again, I'm not breaking any rules. If I do one thing to one side of the equation, I have to do the same thing to the other side of the equation. So I'm not unbalancing anything. This is all legal. And then I get x squared equals 9, right? Which is still true. But watch what happens here. If I now do the inverse again, if I square root both sides to get back to where I started, we get x equals plus or minus 3, right? Which isn't what I told you was true in the first place. I told you x was 3. I said, that's a fact. X equals 3. I squared both sides, which is legal. I square rooted both sides, which is legal. I didn't unbalance my equation. But I did get this weird extraneous solution that shows up, right? X wasn't negative 3. X was only 3. I told you that. So when you square both sides of an equation, when you use that strategy to solve an equation like this, you always have to check for extraneous solutions at the end, because there's a chance I introduced this possible negative outlier that didn't actually satisfy the original statement I gave you. All right. So what we're going to do, I'll start you off now. And this is something either if you want to work through on your own tonight, or if you want to just wait till our Zoom at the beginning of class next time. We need to employ this strategy on this question. We have these square roots, and the only way to get rid of a square root here is to square the terms. So I know there's a way to erase that, but I can't remember right now. What we don't want to do, we don't want to square this whole trinomial. That would be a total mess. So for a question like this, the best order of business to start off with is to isolate one of the radicals. So it doesn't matter which one. Maybe I'll bring this negative 9x to the other side, because that only gives me one step to do. So I have square root of x minus 4 equals the square root of 9x. Now there's a little shortcut on this question, so if you find it, that's great. It makes it a lot easier. But now we can square everything. So we have to be really careful. We have to double distribute this, right? So we have the square root of x minus 4 times the square root of x minus 4. So it's not just x minus 16. We can't forget about those middle and outer terms. This one's easy. The square root of 9x is just 9x. Here we have to be careful. Use your windows if you need to. So the square root of x times the square root of x is x. Now I look at my outer and my inner terms for everyone who did FOIL last year or double distributing. So I get minus 8 square root of x. All right, so minus 4 minus another 4. And then I have my plus 16 equals 9x. So I'm going to pause. You know what? I'll finish this up on my own. I want you to pause. If you want to work through the rest of it, I would actually probably encourage you to. But what we have to do now is just do it again. So we have to isolate this radical term. If you want to divide by the 8, you could. That is not necessary. But we have to just get this radical term isolated and square everything again, and that will get us down to a solution. All right. So pause now. I will finish up my work, and then, then we'll be done. All right, so go ahead and pause. All right, guys, I know I'm right about at my 15-minute mark that I told you I would try not to go over, but I will slowly scroll down here. If you got lost on these steps, we'll talk in class for sure. But I isolated my radical term. I actually was able to divide out by the 8 there. You don't have to do that. I wouldn't create fractions if I can help it. But I isolated my radical term. I squared both sides again. I solved by factoring. And then actually the nasty thing about this question, like I said up above, whenever you square both sides, you introduce the possibility that there could be extraneous solutions. And in this question, I take 4, I take 1, I plug them back into the original, and actually neither of them work. So all that work for nothing. But that happens. All right. Let me know if you have questions. I will see you guys in class. Talk to you soon. Bye.